Okay, good.
Yes, Doctor.
Yeah.
Okay, so what we are doing here, okay, let me just go to introduction to ODEs. Everybody know, in ODE, you have studied some analytic method, okay, meaning the exact method. Okay, some of them are integrating factor separable equation. These are for ODEs. Okay, and then what we have here, how about higher order ODE? Let me just full screen. Okay. How about higher order ODE? How do you solve a second order ODE? Okay, so if you recall your ODE for your second order, you can use characteristic equation. You remember where we have the roots, the equal roots, how you write the general solution, the complex root, how you write the general solution, and also the um, what do you call the distinct root. How do you write the general solution? Okay, your general solution always in this form. Why? Screen is too big. Okay, it will be yx equals to, if you remember, c1 y1 plus c2 y2. Okay, it's always be in this form, the general solution. Okay, and then you have undetermined coefficient, or you didn't, I don't think so, you learn variation of parameter, I cannot remember, but undetermined coefficient here means that you find your yx, you need to find the complementary and the particular solution. Okay, try to recall. This is what you call undetermined coefficient method. Okay, and then you have Laplace transform. Okay, you need to know the analytical solution for this. And then what we have here, so the numerical methods, okay, this is keyword here. The numerical methods to solve ODE, you have linear multiset method, Runge-Kutta method. Okay, this is where you have recalled numerical methods course last semester. Okay, we didn't go too deep to that, but I'm waiting for this class to explain more about that. Okay, now any questions so far? If you have questions, just feel free to ask me, interrupt me. If no, I will just go on. Okay, these are the definition that you have studied before, okay? An equation said to be differential equation, DE, if there is a derivative. That's the keyword. What is a differential equation? If the equation contain derivative. Okay, this is the simplest form. Y prime equals to f of xy, where your x is the dependent variable in time, or y is the dependent variable. And when you have this thing here, everybody know this is called initial condition. Okay, when you have problem, this is called problem plus initial condition. What do you have?
Particular
I
solution.
Yes, thank you. Initial value problem. Okay, problem plus initial condition, you have an initial value problem. Good. So this is higher order. Okay, this is a higher order differential equation. Again, you can have something like this. A(y prime plus b(y double prime). Sorry, I don't want to use second order. I just want to use first order. Okay. So a(y prime equals to 0, let's say. What do you call this? When gx is 0.
Yeah. It's called what? J.
Anyone else? Tanu?
I know what this is.
Tana.
Homogeneous.
Yes, homogeneous. You have homogeneous equation. Okay, when gx equals to 0, we have homogeneous equation. And also this first order. Okay, so you need to know that. It's like we are recalling ODE now. Okay, we haven't come to the PDE part. Okay, existence of a unique solution. Okay, I'm pretty sure this same slide is in your ODE. Let an minus 1, these are the an, the constant just now. Okay, in front of you, there's this one, there is this term here. These are all the constant here. Okay, the solution is unique. Okay, if it's continuous on every interval and subjected, this is the main point here. An here cannot be equals to 0. Okay, then you say there exists a unique solution. Okay, for second order, the solution curve must pass through a point. Okay, this is for second order. For first order, you must make sure there is this A here. See? What happens if A is 0 here? You have by equals to 0. What is by equals 0? Can you find a solution here?
No.
No, that's why it's not a unique solution. Okay, so make sure my A is not equals to 0 for the solution to exist and unique. So I think this is the same example in your ODE. Unique solution. Determine whether the initial value problem given below has a unique solution. I can see it. My A3. This is my A3, A2, A1, A0. My A3 is not equals to 0. Right? So it's unique. Okay? The solution is unique. Okay, any questions so far? Okay, please revise my ODE. Look at the examples again. I'm just reviewing now ODE. Okay, I'm going to go on. System of differential equation. Okay, so earlier on, you have like this. Y prime equals to f of xy. Okay, now if I have y1 equal to x of y1, y2 prime equals to f of xy2 is more than one dimension, you call system of differential equation. Okay, instead of one dimension we have two dimensions, so we have system of differential equation. Such a system is convenient to write in a vector form. Okay, this is the vector form. See, sometimes the problem write as y prime equals to f of xy. Okay, and then they will say where y prime contain all this stuff, y1 prime, y2 prime, let's say. And then this f here contain f1 x y1, y2. Okay, just with it. So y2, and then f2 contain x y1, y2. Now what we have here, two
What?
dimensions.
Two.
Okay, and then my y prime, my x naught, contain of y10, y20. So we have a two dimension here. Some question just give flat and then the rest will be in the form of vector. Okay, so we must know. Okay, don't just look at this y prime equals to f and say this is first dimension. Okay, so check whether any additional information given. I'll show you an example of system of differential equation soon. Okay, so differential equation DE, okay, DE is talking about DE. It is not talking about ODE. What it mean? Who can tell me? Anyone?
Maybe it's wide. How to say the range is wide, not just only ODE but PDE also.
Yes, thank you, Tan. So it's not talking about ODE now. Okay, now we're talking about system of differential equation, right? The meaning is talking not just ODE, PDE and ODE arise in problems in all disciplines such as physics, biology, economic, chemistry, and engineering. Okay, now it's breaking down to biology. Okay, what's the application of biology? Okay, some of your assignment will be more on this. Okay, I remember I told you you got to take a video of something. I'm still thinking about it, but it'll be something about application type. See, a DE modeling of an outbreak of a disease. Okay, so when you have ODE, what would you do? The question will be more on prediction. How long will be the outbreak? Like now we have COVID-19, right? So if we have enough data in ODE aspect, we collect all the data, we come up with the mathematical modeling of the equation, and then we can predict how long the outbreak of the disease will last. Is it going to take 2 years? Is it going to be 5 years? But this is a worldwide problem. So your data has to be a lot. Your data has to be a lot, and you need to have like a supercomputer to run the analysis. We cannot use Scilab or MATLAB just to simulate the data. Okay, so that will be something involving ODE. Okay, but if there's something about the flow of the disease in your body, okay, flow, I mean the, what do you call it, the I don't know, the flow of the disease, or how when the disease enter your body, what's gonna happen, cause that will more into PDE. Okay, I hope you can get the difference between what is PDE and ODE. Okay, see, it's question something like number of infected individual, predicting the number of infected. These are all ODE. Okay, and then in biochemistry and biochemical reaction, the law of mass action is used to depict the rate at which various chemical interact. Okay, what it mean here? Another way is in biochemistry, the rate of change of a concentration of a compound. Okay, so meaning you have some chemical reaction, the rate of change. I think we have studied in application for ODE. You have R in plus R out. I can't remember actually. What do you call it? The equation here. Okay. Rate of change. Something. D over something. Okay. So this is to see the changes when you add the chemical. Okay. And then in physics, we have the application for planet motion of a planet, such as Kepler problem. What is Kepler problem? Kepler problem is a problem that describes the planetary motion of the sun and the earth. Okay, what it mean? We have the sun and the earth. We want to see the movement. How long? In, let's say we have this sun here. Okay, how long? Like what's the age? What's the age? How long this thing there, and the motion for this on the earth, what happened? Okay, these are all, we can go deeper into that, so you got to do lots of research on your own. Okay, this is one type of ODE problem. We call it the Lotka Volterra, predictor and corrector prey. This is two dimension. Okay, this is a population. We call it a population type of problem. This is two dimensional problem where X is the number of prey. Okay, Y is the number of predictor, and then dy dt represent the growth rate of two population at the present time. Okay, and there are some constant here that describe the interaction of these two species. Okay, this is a two-dimension ODE problem. Is it linear or non-linear?
Um,
Anyone?
Is that non-linear because of x and y?
Yes,
I
thank
don't know.
you. This is nonlinear because of x and y. Okay, it's a nonlinear problem. Okay, and another example just now. Okay, this is the chemical reaction example. So the reaction involves combination of two molecules, A and molecule B. Okay, you can also come up with the three-dimension system. Three-dimension system. Okay, system of equation. This is also we want to say how the reaction involved in terms of time. Okay, this is also an ODE problem. And this is a Kepler problem. Okay, it's a second order. This is a second order differential equation. Second order DE. Okay, so what happened here? This is the value of R. This is the value of Y. So if I plot this graph, I can get a perfect circle. Perfect circle. The exact solution is a perfect circle. Okay, and then what you do here, now I'm using the exact solution is difficult to compete, so I can use ODE method such as Euler method or Runge-Kutta method, any method. So you can see that if the method that I'm using can overlap, that means I can use that method. It should be overlapping. Okay, that means I can say the numerical method can be used to investigate more. Okay, what is the motion between the planet and the sun and the earth? Motion in Malay, what do you call? Anybody knows? What do you call motion?
Pergerakan.
Pergerakan. So that's the correct word? Yeah, pergerakan. So pergerakan meaning, so when I say the sun and the earth, so apa maksudnya? Siapa boleh terangkan? Pergerakan matahari dengan
Berputar.
Yeah.
Pergerakan bumi mengelilingi matahari mengikut paksi dia.
Yeah.
yes, maybe that's the correct word. So kita nak tengok, so apa yang kita nak tengok ODE ni? Kita nak tengok pergerakan antara matahari dengan earth. Okay, kita nak tengok macam mana. Berapa dalam satu putaran tu, berapa lama dia ambil. Is it something like that?
Yeah.
I'm asking you guys a question, okay?
Dalam
Yeah.
1 minit tu berapa degree dia bergerak.
Okay. Kenapa nak tahu? Bukan ada orang nak buat.
Tu lah tu.
Okay, so what happened here? Okay, what happened? I mean, it's correct. Kita nak tengok putaran tu berapa lama. Okay, so what happened here? Adakah dia masih daripada tahun billion years ago until now, is it the same? Ada beza tak? Okay, so people such as the astronaut ke ataupun NASA ke, sebelum dia nak pergi ni space, dia akan check dulu lah. Dia akan check dulu, oh, they are the same thing. There's no changes. They are still the same thing. Okay, so will there be any changes? Yes, there can be a little bit of changes when timing to timing. Okay, kadang-kadang kita tahu apa the sunrise and sunset are getting different time, is it? Sometimes it's getting earlier, sometimes it's getting later. So this has to be something involving to it. So if you want to do more research, you have to read about it, okay? The name Kepler here is given by the person. The person name is Kepler. And I forgot the date, okay? So just we can do it more. We can study about this more when your group assignment, okay? So he found out this mathematical second order DE. Okay. Now, how can we solve this second order? Did you learn in your ODE? You didn't learn how to solve a second order system. right? You learn a second order equation, but not a system. Okay, that is a way. That is a way. I'm going to explain to you soon. Okay. So what happened next now? Hold on. I'm just finding my, I don't know. Okay, let's move on. Okay, so these are the terms and terminology. So I've given you some example about application, little bit background. Okay, now look at all these terms and tell me. I have number one, two, three, four, five, six, seven. Okay, how many of you know from 1 to 7? There must be some you already know.
Order of course, linear and nonlinear,
Initial constant. Boundary
Okay,
condition.
boundary condition semua tahu kan? Semua term ni, okay, ni mungkin ni tak pernah dengar. Okay, but all these term you know. What is order?
it's the derivative
Highest
order of
power of the derivative. That's right. Highest power derivative. Linear. You know what is a linear equation?
only
Okay.
x, only
If non-linear, if you have the power
yeah,
power more than one, will be a non-linear equation, and then you have initial condition, boundary.
what,
Okay. Okay. Initial condition is like this: y x naught equals to y naught. Boundary
yeah,
condition is like this: y x naught equals to
x
y
not
naught, and then y xn equals to y n, I will say lah. Okay, there are different here. See here, x naught y n. There are two. Yes.
okay. Okay, so if I say y x not y not and y prime x not, then y prime x not is equal to y n can be a boundary condition, doctor.
Okay. Thank you. That's a very good question, Tan. Okay, I'm going to erase this. Let's come up with a few type. Okay, so we have y x naught equals to y naught. And then we have y prime x naught equals to y naught. Is this initial condition or boundary condition?
Boundary, I think it's boundary. I
Yang
think it's
lain?
boundary.
Yang lain? Shida ada?
Condition.
Syamil, Syamil ada Syamil?
Sure.
Ada, doktor, ada.
Syamil, good to hear you, Syamil. Okay, boundary ke initial?
Initial.
Yes, initial. You know why? Why x naught and x naught? It's at
Oh,
one point. Boundary, when you have the boundary
more than
x naught,
oh,
let's say x1 or xn, I said, because we don't know. So this will be boundary condition. So the same now, x naught equals to y naught, y x naught equals to y naught, and y prime xn equals to y naught. Now this is boundary condition. You
oh,
see the
because of x and xn, right, doctor?
yes, Tan. Boundary means you need to have two different set of x.
Oh,
If it's just one x, which is the initial only, you call it initial condition. This is initial condition, this boundary condition. Clear, Tan?
clear, doctor. Thank you,
Okay,
doctor.
good. Okay, we know what is order, I've already explained. We know what is linear, I've already explained, but we don't know what is autonomous. Okay, class, pay attention. A problem to say non-autonomous if fx only depend on the independent variable x, not y. What that mean? Okay, hold on a second, your thought. Fx only depend on the independent variable x, not y. Okay, if it's autonomous, f is a function not of x but y. So meaning, okay, listen. We have f, we have y, prime equals to f of x, y? We have y prime equals to f of y.
X. Right. Oh, okay.
When we have this one, we call it
Auto.
autonomous. When we have this one, non-autonomous. So sometime your problem, you have something like this. Y prime equals to minus y. It's just like that. So this is autonomous. Sometimes you can have problem like this. Y prime equals to x minus y. You have non-autonomous. Did you get the idea? Okay. But then
Yes,
it said that it is always
yes.
possible to write a non-autonomous into an equivalent autonomous form. So sometimes we have this non-autonomous, you can write it in terms of autonomous form. It is possible. Okay, that's why sometimes, let me just erase it. Sometimes I won't be worrying about my x too much. Okay, I'm worried about my y value. Okay, because when you are solving a problem involving x naught, I put it x1, x2, and then you have y naught, y1, y2, and so on. This x is the increment of the h. X naught will be x naught plus h, you have x1. X1 plus h, you have x2. X2 plus h, you have x3. You don't have to worry about x so much, but you have to more focus on this y here, because this is the y you can use your numerical methods to find. Okay, that's the key point. Autonomous and non-autonomous. Okay, you know what is initial value problem? If a condition problem given with the initial condition. Okay, I don't want to explain more. And the boundary condition, there you go. Here, the key point here. Okay, x naught and xn. Okay, we have initial, we have boundary value. We have boundary condition, sorry. This is the problem. This is the boundary condition. So we have boundary value problem. Okay. Okay, now types of differential equation. You only know these two types, ODE, PDE. There are actually many more that we are not going to look at unless you want to further study to a master or PhD. We have delay differential equation. This is a type of equation that usually will come in this form. T minus 1, t greater than 0. We call it a delay differential equation. So we have y prime. And we have stochastic. Yes.
I don't know why when Doctor give the example, that's what I think about Laplace. Like like ODE last semester, last class, Doctor has make a questions about piecewise. Is that called a delay?
No, 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 no.
Okay.
This is y prime. Y prime, right? Your Laplace equation usually start with your piecewise equation always start with yx.
Okay. Not
Okay?
y prime x, right, Doctor?
Yeah.
Mm.
Again, this one should be t actually. Yt because my involving t. Okay? Now, stochastic differential equation where you use to predict the stochastic type of problem. Okay, usually you won't study it unless specifically at certain university. Okay, like when I went to further my study, that lecturer was focusing on stochastic instead of ODE. It's just a type of differential equation, and differential algebraic equation also. We are not going to look at these three, so don't worry about it. If you want more information about this in the future, I can always share. Okay, so we're going to focus on ODE and PDE. That's it. Okay, now we are coming into the theory of ordinary differential equation. Okay, so before we go on, I would like to say that you have to use Scilab. I put a slash MATLAB or slash C++, any programming tools that you have learned to solve problem. Okay, before we have looked at second system of equation, right? Just now, system of the is difficult to solve system of DE. However, you can reduce it to first order system. This is something you never learn. Okay, look at here this problem. Write the Kepler problem into a first order system. Okay, let's look at what's the Kepler problem just now. Go back to the Kepler problem. Okay, this is second order. Y double prime 1 equals to negative y1 over r cube. Y2 double prime equals to negative y2 over r cube. Now you want to reduce this to first order.
Or
First order. Then only easier for you to solve. Okay. So you can do that. So this is how you do. Okay. Let y1 equals to y1. Y2 equals to y2. Y3 equals, okay, what I do here, let me just explain here. Okay, we have y double prime 1 equals to negative y1 over r3. I want to write the equation correct. So if you have your slide open, just check. I don't have my slide. Okay, y1 double prime equals to okay, this is correct. And then y2
cube dot.
double prime equals to negative y2 over r3. Okay, this is your second order. Okay, now how can
Uh,
I? Yes, Tan?
it's R cube actually. When I see this one, I don't know it's R3 or R. Here is the R cube in the slide is R cube. If I'm not
Yes,
mistaken.
you are right. You are right. Okay. R cube, R cube. Okay, correct. Thank you. So now what we want to do here, how to write this into the first order differential equation. Okay. So identify all your variables. That's the first step. Identify the variables. So from my observation, I have y1 and y2. So then you write y1 equals to y1, y2 equals to y2. That's the first step, okay? Now from here, what I do, I can write y3 equals to y1 prime, and then y4 equals to y2 prime. From here, I have y3 equals y1 prime, y4 equals to y2 prime. And now I'm going to arrange this into a first order, such as y1 prime is y3. I hope you're watching and writing. And then y2 prime equals to y4.
Y4.
What is y3 prime? Look at here. Y3 prime, my y3 here. If I take a prime, it'll be y1 double prime, which is this one.
Double prime.
The given y1 double prime is negative y1 over r cube. Are you with me?
Yes, doctor.
And now
Yes.
y4. If I take y4 prime here, this equation here, it will be y2 double prime. Are you with me, class? This is how you transform second order into a first order differential equation. It's a bit tricky, right? So first thing is to identify the variable, two variable. Okay, this is the two variables. And then you have to write the prime for this given variable. So you will add another two more, because you will write y3, which is y1 prime, y4 equals to y2 prime, and then you arrange it. Y1 prime is my y3, which I've declared, and y2 prime is my y4, which I've declared. And then taking the y3 prime will be y1 double prime, which is this one. And then y4 prime, which is my y2 double prime, which is this one. Is that okay, class? Okay, maybe we'll, yeah.
Luckily the video is recording. If not, I will forget a lot.
Okay. Maybe when you do more example, you will get it to it. But so far, I want to ask you, is it clear?
It's clear for me, but I don't know
Yes,
about
yes.
Clear, Doctor.
Doktor,
Tulisanmu jelas
doktor.
Ya, ya.
Jelas.
Adakah dia punya untuk daripada second order ke first order tu, kalau dalam contoh ni kan dia sama je.
Apa yang
Tapi
sama?
dia punya solution tu, dia punya equation tu. Kalau doktor tengok.
Equation
Kan
tu
dia-
takkan banyak berubah. Ya, betul.
Ah,
Cuma yang akan berubah adalah, okay, beza dia adalah ini first order yang kita dah transform dan original. Second order dia macam ni. Where is it? I want to erase this. Erase. This is my second order. Nampak? Pattern dia dalam second order tu kena ada equation dia balik lah. Kalau tidak, apa yang kita tukar tu salah. Equation ada. No matter what, equation ni kena ada. Tapi instead of double prime, dia dah semua tukar kepada y prime. First order.
prime.
Yes. So, if you look at, if you have y1, y2 with double prime, dia akan jadi 4 by 1 system. Okay, dia akan jadi 4. If I just have y double prime, dia akan jadi tukar kepada y1, y2. Single prime. Okay, maybe by looking at more example lagi nampak lah. Okay, we'll look at it later on. Okay, so why is it better for you to transform? Because it's better to use Scilab when it's a first order. Second order ni a bit complicated to use the Scilab because you have to do the derivative twice. That's why we want to reduce it to a first order system. Okay, now we want to go on to what else? Okay, now you guys try. Convert the following second order problem. Macam mana? Macam mana nak convert? Apa variable yang ada? U.
U, T. Okay, let me see. I don't have to watch this one.
Okay, anybody want to try?
Already have the solution actually, doctor.
Yeah, I've already given it. That's the problem. Okay, so what I did here, let V equals to du dt. Okay, V equals to du dt. So we have V equals to du dt. Maybe usually you write here will be du dt equals to V. Okay. Okay, now what is dv dt? This is my du double prime, right?
Yep.
Double prime. What is my du double prime? Du double prime is this one. Yeah. So we have g tu du dt is v. So I have g tu du dt, which is my v.
V.
Now instead of second order, it has reduced to first order. Now you don't have to use v. I can use m. Doesn't matter. Okay, I don't have to use kalau ada yang buat let me just erase it. Okay, ada yang nak buat macam ni pun boleh du dt equals to m, dm dt equals to g tu m. It's also acceptable because the variable is sign. You are the one letting it. You can use any variable you want, but make sure you transform it into first order. Okay, that's the key point. And of course, when you transform your problem, your initial condition change too. Okay, what is the initial condition given? This is remain the same, but this one, du dt, which is my v0 equals to b. Okay, if I use m variable, nanti ditukar m0 equals to b. Okay, you can use any variable to start with. You don't have to use b. Okay, class? Okay,
Okay.
go on. Okay, ini pun dah tahu existence and uniqueness of a solution. So, tadi kan saya dah bincangkan, I don't know why. But, oh yeah, we want to make sure that we are solving a well-posed problem. So, what is a well-posed problem? Solution exists. Well-posed problem is a problem where solution exists and is unique and how sensitive the solution to a small changes. Perturbation means small changes. Okay, so this is what it means by well-posed. Okay, ada solution. And then solution unique. What is unique? The previous slide I told you. Unique means the differential equation, the A, whatever in the front of equation, not equal to 0. And how sensitive to the changes. Sensitive terhadap perubahan. Okay, meaning if you change your time value, what will happen? Okay, now to make sure the problem is well posed, you need Lipschitz condition. Lipschitz condition yang menentukan sama ada problem tu adalah well posed or not. Okay, because this is important to study the behavior of numerical approximation. Okay, this is a Lipschitz condition. Okay, usually I don't like reading a theorem. It's more better if you do example. So we will look at example in the future lah. Tapi condition ni said, if you are given a function A that exists in this interval, this is the sign for interval, interval. Okay, and then you compare with the constant L, which is known as the Lipschitz constant. Okay, the difference between y minus z multiply with this constant here must satisfy this condition. Okay, where the function must be less or equal than whatever when you minus the two variable, multiply with the constant. If this exists or true, we say the problem is well posed. Okay, well posed ni penting sebab kalau problem tu not well posed, such as the problem is not unique, there's no solution. There's no problem solving it. Okay, this type of problem mostly, okay, let me just comment. Mostly every problem that you are using is well posed. So tak payah check Lipschitz constant. Lipschitz constant ni you check bila you baru nak terbitkan equation or a problem. Misalnya you nak predict pandemic COVID-19 kan, you nak come up with your own mathematical modelling equation tu, you nak terbitkan your first equation. That means you kena check whether they're unique, whether the solution exists. Okay, but for our case, we are using all the problems that are already exist. So kita tak payah nak check lah. Okay. Okay, what is this? This is addition to the theorem just now. It said that the Lipschitz condition exists a unique solution. Okay, sama lah. Okay, we are almost to an end. We are almost coming to an end. So, actually we have come to an end for the first chapter, which is the introduction part. So, this is the class exercise. Okay, it's in your slide too. Okay, so the first question is transform the following fourth order into a system of first order. And then the initial condition as well is given. You don't have to solve. Saya nak you transform sahaja. Transform only. Okay. And then show how the initial condition can be written as an autonomous first order. Maksudnya apa? Transform juga. This is another way of saying kita transform. Okay, this is second order. You want to change to a first order. Tapi dia kata autonomous, maksudnya dia depends on Y only, not X. Okay. And then you have another second order simple harmonic oscillator. Okay, show that the exact solution. Tengok ni. This one is actually I can write like this. Y double prime plus 0.2 Y erase it. X double prime plus 0.2 X prime plus 1.01 X equals to 0. Second order homogeneous equation. How do you find the exact solution? You have to find the root. Yes, thank you, Tan. So get a characteristic equation, check the roots, see what type is it, and then you should able to get the okay. And then what does it say? Write the given second order IVP. Now this is second order. Okay, this is second order. Transform this to a two first order system. Okay, what's two first order system? Dia dah kata y1 equals to x, y2 equals to x dot. X dot here means x prime. Okay, so you will have something like y1 equals to x, y2 equals to x prime. Tak susah Let me just tell you how to do it just quickly. Lepas tu bila saya ambil x, y2 prime. Okay, tengok apa jadi y2 prime. Meaning x double prime, right?
Double prime.
Which is this thing here. So x double prime, semua yang lain bawa pergi ke sini. I have negative 0.2 x prime minus 1.01 x. Agree with me?
Agree, Doctor.
Okay. Negative, so I have negative 0.2. What is x prime? y2. Minus 1.01. What is my x? y1. Are you with me?
Yes, Doctor.
Yeah, and then what is y?
Yes.
What is y1 prime?
Y1 prime, Y2.
It's my x prime. Yeah, y2. Very good. Nanti you susun balik lah. Tulis y1 dulu, baru tulis y2. So I've already done for you B. Saya dah tukar B ni kepada second order. This is the answer lah. But I want you to do the rest. And the initial condition. So initial condition akan berubah lah. So this one will be, this is x prime 0, right? Which is y2 0 is 0. y1 0 is 1. y2 0 equals to 0. Okay, that is 3 exercises that you can do. Oh, that's another one. Okay, given the differential equation. Okay, this is the differential equation. Same thing. Okay, class, is this boundary condition or initial condition?
Initial condition.
Yes, look at here. Tak berubah x dia. So initial condition. Okay, find the exact solution. You should be able to find the exact solution for this. Find an equivalent autonomous first order. Tukar balik. Transform to first order.
So meanings that, Doctor.
Yeah.
Doctor. So means that if we see the questions called find the exact solution, just change using the characteristic equations or else?
Depends on your type of problem. If this second order, you can use exact solution. If it's first order, you use separable variable or integrating factor.
Okay.
This is your ODE. Okay, that's why we have to recall our ODE in the beginning. Okay, so we have 4 questions here. 4 questions here.
Doctor,
So yes, Tan.
sorry,
Yeah, sure.
So the exact solution is just the basic from the
ODE.
ODE, right? If I'm not
Yes.
mistaken.
Exact is
Okay.
the basic ODE. So why we need to know the exact for numerical method? You need to know exact because when we want to compare with your approximate solution later on. I haven't. If you look at this, there's no that say solve. Ada tak? Tak ada kan? That means you cannot solve yet. You are just learning some basic. When you say solve means then you learn a numerical method to solve it. Once you solve it using numerical method, you can compare with your exact solution to check the error. Okay, that's why exact solution is very important. Okay, looks like I have talked more than 1 hour. So what I want you to do, say you don't have to submit this exercise. Okay, there is no marks for exercise submission. Okay, so but what we can do, what I want you to do is you do it. I have open on my guru in forum. If you want to put your answer there, you can put it. So that when we start next week class, I am going to call one of you. How many of you are there? 50 students here. Oh, everybody present today. Good. Okay. Syamil, mungkin saya panggil nama Syamil. Minggu depan minta you share. So, you dah tulis tangan kan?
Jangan betul.
Cubalah Syamil. Saya nak betul-betul you usaha this semester. Okay? Bincang dengan kawan. Cuba buat. And then saya panggil. Okay. Shazana ke, Siti Aisyah ke. Please explain to me your solution. Nanti you kena share screen lah. So that's why I say you can use your laptop instead of your phone. Okay. Bila laptop tu you boleh share screen. Kalau phone nak share screen pun boleh. Tak ada masalah. Okay. And then I want to see how you do it. You explain. Because we have this teamwork. Evaluation for teamwork. So by now you should have your own team, right? Later on, one of you please give me the list of your team so that every time I call your name, I want to make sure I don't call the same person. All your team members are cooperating lah. Okay, class? That's all actually for today. Next week, kita akan tengok Euler method. I hope I'm not going too fast. Okay, because you have already have the notes. So we're just going to recall the notes one at a time, one by one. And to be honest, I haven't done any video for this course. I'm going to go slowly.
Doctor,
Yeah.
so our list of the group assignment
Yeah.
group,
Yeah.
assignment group, we need to submit on Google Meet or on WhatsApp?
WhatsApp, just submit to me the list of the name so that when next week class, I know who are you, I mean, what are your groups. Okay, just share to me after this class. Okay, yang lain semua okay Semua okay. Shida, I heard your voice many times. Welcome back, Shida. Mana Shida? I heard her voice many times today. But
Tak ada line doktor, dia cakap suara doktor tersekat-sekat.
oh ya ke? Oh, that's really bad. Mungkin sebab Chromecast kau. Yang lain suara saya macam mana hari ni?
It's okay for me, doctor.
Okay, doktor.
Sangat okey doktor.
Sangat okay Okay, saya nak tengok sebab group yang lagi satu group C++ ke group apa entah saya dah lupa. Saya guna screencast bila saya share balik audio tu very bad. Dia tersekat-sekat, suara saya sekat-sekat, explanation whiteboard pun sekat-sekat. So saya dah ingat tak nak guna lah. Okay, I'll look at today's one how, but I'm trying to change it to Microsoft Team. Instead of using Google Meet, saya nak cuba guna Microsoft Team. Okay, tapi we'll see how. Starting today, I really like Google Meet. For me, Google Meet is something I'm quite used to it. Okay, that's all for today, class. Do you have any question?
Doctor, about the Scilab, what version should we download?
The latest version, Tanu?
Latest version, okay.
Yeah,
okay.
latest version. So I think
Hold on a second. Hold on a second about Scilab.
Yeah.
Hold on a second about Scilab. because I have this kind of problem too about the additions. So if your addition has the problem just like mine, you better change to the other persons.
What is it, Tan? I don't understand.
Okay, I mean because on the previous semester, doctor has found out my problems during using my silent.
Oh yeah, I remember you have a lot of
Yeah,
problem. Let me see what version I'm using.
yeah,
So I am using 6.0.1.
yeah. So better if your problem right now it has a problem problem of the software, you better change to another version
Okay.
until the version is really good for you. Is
Okay.
get the answer.
Okay, semua faham ke
Yeah.
apa yang Tan sangat marah ni? Okay, calm down, Tan. Calm down. Okay, so
No.
what Tan is saying, last semester on numerical method course, he just couldn't figure out the error for a code. And we've been trying to figure out the code. Error dia adalah disebabkan version yang Tan gunakan tu ada problem, if I'm not mistaken. So what he's saying, you download whatever version that available. Let's say the latest version, you download it. But let's say there are an error that everybody else don't have, only you have. Even I check your code, I say the code is fine, there's no problem. And but the problem will be your Scilab. You kena downgrade your Scilab version. Ambil yang tak latest lah. Sebab dia depends on your operating system. Okay, so right now, download first whatever, because we don't know. We haven't tried the code yet. So we don't know. But Tan, stick to whatever version you have. For those yang ambil numerical method, yang rasa your Scilab is working, stick to it. But for those of you that you never learn Scilab before, sebab numerical methods dulu tak belajar kan? Ada berapa ramai?
Saya tak belajar.
Tanu tak belajar, Shira tak belajar, Vivian Sitan ada belajar? I don't think so. You guys.
Doktor.
Yeah. So you have to work really hard. That's all I can say. Okay. So because we need the help of Scilab to compute some problem for us. Okay. Anything else, class?
I guess no.
Okay. Tan, no. What about the rest? Okay. Fananita. Okay. Fananita, good to hear you. Yang Scilab tu nanti you kena belajar lah. From timing to timing. Melalui video saya ke. Nanti saya akan buat macam ni jugalah. Okay, saya akan terangkan pada screen. You ada laptop you ada Scilab you akan ikut apa yang saya buat, okay? So, I think should be okay. But for today, there is no Scilab. I'm not sure. Yeah, next week we have Scilab. We're gonna look at least half an hour using Scilab. Okay, class, that's all for today. I will share the video soon. Have a good day and keep working on your homework while you can, and share me the list of groups soon. Thank you, everyone.
Thank you, Doctor.
Okay, attendance ada lagi yang tak ni boleh fill up See you everyone. Bye.
Bye, doctor.
Thank you, Doktor.
Okay.
Thank you, Doktor.
Bye, Doctor. Thank you, Doctor.
Welcome.
Thank you, Doktor.
Okay.